So I want to get into talking about halftone image foundations, but with a twist of Flexo on there. I know all you've really done as far as screen work or process color images has primarily been maybe your screen printing with in 2070 and a little bit of screen tints and some Flexo projects in 1040. So I would hope by now most of you know why we have halftones and what screen ruling means, what screen angles are, and the basics of dot gain and what that does to us. So one of the earliest kind of experimentation by George Seurat was actually with his paintings, which he actually did a stippling effect where he just built colors up by just tiny dots or spots of different colors. So he was kind of ahead of his time in his creating artwork, but nevertheless, he had an idea there that we could take into taking something that only allows us to really place color or not, and only ability to like place a specific amount of color or not. So when we look at printing and it being a binary process, meaning on or off, it's either you're going to put ink on the sheet or you're not. You can't put varying shades of black on there, especially when you're talking about Flexo from a static plate that actually has an image raised up off there and it's contacting that analog scroll. You're either going to deliver ink or you're not. So we talk about printing being a binary process. So how can we print these images with multiple shades or multiple colors? Okay, we can't just magically come up with some way of doing that without having to halftone our images or create those patterns of dots. So I've oftentimes referred to this as it's just an optical illusion. Okay, so when we have these optical illusions going on, sorry, I was moving my chat window where I could see it. So when we look at these optical illusions, how good our optical illusion has to do with a lot of what we do in pre-press. So as we create our files, as we build those, we have to have some inputs that we understand exactly what our process is capable of doing. And we also have to understand the limitations of our process based on what the inputs are, such as what kind of, in Flexo, if we're looking at what kind of plates we use, or if we're looking at what kind of inks we're using, or if we're even like looking at the age of our press or the analog scrolls that we have available to us to actually mount and use in that press, or if we have any options whatsoever to make any changes. So when we get into images, okay, now we're not just talking about just screen tints or gradients, although they're kind of in there, okay, on a smaller level, but we've got all these different tones in this image that we've got to reproduce. So when we change that image and make that into a halftone, now we have these dots. We vary those sizes of those dots in order to reproduce those tones. Now, albeit this one is quite coarse, okay? So the coarser our images are, the less likely that they're going to be able to represent our image as well. So we're always trying to kind of push those limitations and going to higher line screen rulings. When we take an image that we have in our file and we're going to transfer that into being a halftone image or 4 halftones for process color, we're going through our RIP. So in the case of our projects that we're dealing with in our Flexo files that are going to eventually make it to plate, our RIP is handled through the ESCO software that we'll be utilizing that actually processes that file based on a certain set of parameters. So we'll have those inputs in there to actually we'll specify screen rulings, we'll specify screen angles, and we'll specify anything we need to do with the dots in order to reproduce those tones faithfully. And we'll have those parameters set based on some foundational materials or foundational information about characterizations that we've done on our printing press. So we take the end points, or we take the end product from a press characterization, or even if we're doing where we're trying to develop a color profile, we take all that information and bring it back into prepress, and we utilize that data that we've collected. So we're going to have some different things that we do throughout the semester as far as looking at what happens to images, and not just an image like this Halfton image. We'll have some test images. We're actually going to be filming and taking care of taking some test images that we're going to show how you go about analyzing both something for like a corrugated, direct print corrugated test, and we're also going to look at a narrow web test image and what kind of data you're collecting off of that. So when we look at line screen rulings, obviously, if we start looking at something like this one only being 14 LPI, now this is not something we would typically choose. This is really just to like look at this from a larger perspective for lecture purposes. So when I look at conventional screening, I've got what we called AM screening. Okay? We've got a number of lines per inch. Okay? So DPI is strictly used for like talking about imaging devices, like anything from a laser printer to inkjet printer to plate imaging, digital plates being imaged. We talk about DPI, but specifically we set aside LPI to talk about conventional AM screening, where we're talking about the number of dots per linear inch. So the dots remain consistent as far as center to center to center. Okay. So if I look at these, there's always 14 dots in a linear inch, but the dots get closer together only because they become larger. So we call this AM screening. Okay? So when we talk about dot percentages or screen tint values, we're just talking about the area of dot coverage per unit. In other words, if it's per linear inch, okay, we're talking about how big is that dot and how much of its little allotted space. Over here we've got 80%. It's almost covering up its entire little grid spot, if you think of this as being a grid. So 80% coverage and only 20% left open, okay, or unprinted. So let's look at, okay, again, this is small dots to large dots. So we call this AM, or amplitude modulated. Okay, modulation meaning change. So we only change the size of the dot, okay, which is what amplitude means. So the dot size changes, but the spacing remains equal. Okay. So what's so significant about this? Why do we care? You're going, why in the world do I really care about the difference between this and some other kind of screen? Well, because we will see in flexo printing where we typically don't use just AM screening, or if we do use AM screening, it's quite different in how we have to accommodate the use of that, utilizing when we're preparing files for flexography compared to screen printing, compared to offset lithography, and even comparing different press configurations or sizes of presses or the substrates that we're printing on. So you see a huge range. There is no standard dot gain curve for flexo like you do for offset. Okay, so there's differences for different market segments and different substrates and different presses and different press sizes and things like that. Okay? So when we look at choosing higher resolutions, okay, those dots start getting finer and finer. So if we look at this is a 50% dot, okay, meaning it's covering up 50% of its allotted grid. Okay? and 50% is left unprinted. So typically with flexo printing, if we use AM screening, it's usually a round dot. There's in offset lithography, we use elongated or elliptical shaped dots. Okay, so they kind of look more like a chain going across there than these individual round dots. And there's a reason for that with flexo, because it helps to print cleaner. You get less dot bridging and problems like that.